Hi folks. Welcome. What is logistic regression in machine learning? Logistic regression is a type of supervised learning algorithm used for binary classification problems, where the goal is to predict a binary outcome, example, yes/no, 0/1, based on one or more input features. The logistic regression model uses a logistic function, also known as the sigmoid function, to map the input features to a probability value between 0 and 1, which represents the likelihood of the input belonging to the positive class. The logistic regression model then predicts the output as 1 if the probability is greater than or equal to a threshold value, usually 0.5, and 0 otherwise. The model is trained using a labeled dataset where the inputs and outputs are known, and the objective is to minimize the error between the predicted and actual outputs using a suitable cost function such as the binary cross-entropy loss function. The weights of the model are updated iteratively using an optimization algorithm such as gradient descent until the cost function is minimized. Logistic regression is a simple and efficient algorithm that can be used for a wide range of binary classification problems. However, it may not be suitable for complex problems with nonlinear decision boundaries, where more advanced machine learning algorithms such as decision trees, random forests, or neural networks may be more appropriate. Here are some examples of binary classification problems where logistic regression can be applied. 1. Email spam detection. The goal is to predict whether an incoming email is spam or not based on the email's features, example, sender, subject, body content, attachments. 2. Credit card fraud detection. The goal is to predict whether a credit card transaction is fraudulent or not based on the transaction's features, example, amount, location, time, merchant. 3. Medical diagnosis. The goal is to predict whether a patient has a certain medical condition, example, diabetes, heart disease, based on their medical history, lab results, and other relevant features. 4. Customer churn prediction. The goal is to predict whether a customer is likely to cancel their subscription or leave a service based on their usage patterns, demographics, and other relevant features. 5. Loan default prediction. The goal is to predict whether a borrower is likely to default on their loan based on their credit history, income, and other relevant features. In all these examples, the logistic regression algorithm can be trained on a labeled dataset of examples where the inputs and outputs are known, and then used to predict the output class of new examples based on their input features. That's all, folks. Keep learning and keep growing. Thank you.